We are talking about significant events that happened to the battery industry in 2025 and using as our resource the about to be released 2025 Volta Battery Report. We're very excited to have four of the authors here to discuss this with us. We're going to talk to Nika Kafeety, who is Product Marketing Manager at PDF Solutions, Nicolina Nanni, who is Head of Product at Liminal Insights, Charlie Parker, our old pal Charlie Parker, Principal Consultant at Ratel Consulting, and Maithri Venkat, who is the Director of the Women in Batteries Program at Volta Foundation, as well as working for Lucid Motors. So welcome. Charlie, I'm going to start with you.
Sure. Okay. This year I had the pleasure of authoring the Robotics and Drones section applications in the battery report. It's very relevant this year. They have been in the headlines, policy pushes, and a lot of macro factors going into these applications that are now front and center. So when we talk about batteries for robots and drones, we're really talking about how energy storage shapes system behavior. These platforms don't just need energy, they need instantaneous power, rapid recovery, and predictable performance under highly variable conditions. Unlike EVs or consumer electronics, batteries are here operate inside assets where uptime, mission success, and flexibility often matter more than cost per kilowatt hour, which is very important. For small unmanned aerial systems, batteries directly define what missions are even possible. Every improvement in energy density doesn't just extend range, it expands operational envelope. Heavier payloads, longer loiter times, or fewer charging stops per day. What's less obvious and critical is how drones designed around power transients, takeoff, hover, wind correction, and landing all demand short bursts of very high power. That's why battery performance improvements unlock more than linear gains. They create disproportionate operational value, especially when paired with hybrid architectures. From an operator's perspective, this enables a shift away from redesigning airframes towards configuring energy storage as a variable input. Batteries become a tool for matching missions to payloads rather than forcing one drone to do everything. And slide 2, we get into robotics. That same idea, batteries as a configurable system input rather than a fixed component, becomes even more important when we move from flying machines to robots that operate continuously in the physical world. In humanoid and mobile robots, batteries stop behaving like a dominant cost item and start behaving like replaceable infrastructure. These systems are expected to work multiple shifts in unpredictable environments with frequent high power motion. Because the battery system represents a small share of total system value, the optimization problem changes. Designers prioritize life cycle, fast recharge, thermal stability, and serviceability over absolute cost. As fleets scale, demand is driven less by new unit sales and more by installed base, repeatedly consuming energy in replacement packs. This is fundamentally different demand model than EVs and closer to industrial equipment or aviation, where battery performance directly influences utilization, labor substitution, and total economic output. The big takeaway is robots and drones. Batteries aren't just enabling mobility, they're shaping business models, fleet economics, and system design. Performance, not price, is ultimately what scales in these markets.
All right, I'm going to turn next to Nicolina Nanni, Head of Product at Liminal Insights. And what have you got for us?
Thank you, Michael. So today I'm going to talk through some advancements in AI and ML enhanced production and quality control. This is something I spend all of my days in this space, understanding who is really leveraging data and bringing data to the factory floor, taking it from the factory floor and utilizing it across the factory to improve quality control. AI and machine learning are central to battery manufacturing QC. We know that, and that global leaders across different scales of manufacturing are all investing energy in-house to AI and machine learning. There are dedicated teams with the directive to manage the variability, improve the yield, adopt new technologies that help them reduce costs overall. And while there are companies across the manufacturing process and value chain that are introducing new AI capabilities as the tools become more widely available and trusted. Almost every machinery company or software company is really pushing that AI capabilities, the increased efficiency and value that can be gained. While there's also new AI native companies like Ars Machina, Smart Battery Analytics. So this is a new section here, the AI native companies that are there to change the way the factory runs and operates and by leveraging AI. So this is one. Liminal myself is in the sort of end of line QC space, and we're seeing more companies come there as well with AI capabilities, wanting to close the loop with the upstream technologies and bring these data sources together. So I think this is really exciting, and we're going to see more of it and more really powerful applications of AI and machine learning as we do start to leverage and bring these data sources together.
Let's go next to Nika, and let's see what you have to add. Thank you.
Right, great. Thanks, Mike. All right, so I worked as an author alongside Charlie and Jerry on the manufacturing section of the report, where we discussed the key manufacturing trends, show different process maps, new process technologies, and highlight some innovative solutions like Nicolina's slide on AI and quality control, as well as the software section. So I think it fits very well in the theme of our conversation today. I'll start with the manufacturing section. I'm not going to go over this summary slide, every single box, but just some key numbers. So battery production surpassed 2.3 terawatt hours. Another important thing to note is the industry. We pivoted from NFC to LFP, and this is driven by cost and safety benefits of the technology, as well as AI data center demand, ESS growth, and lower EV-related procurement. Tier 2 Chinese manufacturers gained share in ESS, and the leaders like CATL and BYD remain. Go to the next slide. So I'll start very quickly with the Gigafactory maps, because this is one of the most telling visuals in the report, and it's actually the slide that's one of the most, if not the most viewed. So what stands out in 2025 is that this is the first year we see a net reduction in Gigafactory capacity in North America, with roughly 460 gigawatt hours delayed or canceled. That's not because batteries aren't needed, but due to EV demand softness and the end of US tax credits. It's also important to note that in the US, 190 gigawatt hours was reallocated to LFP, just to reiterate the trend that I mentioned. In Europe, we see a similar story. Capacity actually shrunk by more than 360 gigawatt hours, driven by weak demand, energy costs, and project financing challenges. Several plants are technically announced, but functionally paused for now. Meanwhile, China continued to expand aggressively, even with global overcapacity. Leading Chinese manufacturers kept building and increasingly shifted capacity towards LFP and ESS, or toward ASEAN countries to manage trade exposure. The key takeaway from manufacturing this year is not just scale, but it's rebalancing the industry. The industry is moving away from where capacity was planned toward where demand actually showed up. So next, on the software side, so in the report, we don't treat AI as a single thing. Instead, we look at how it's being explored across the whole battery life cycle. So from research and product development through manufacturing into operation maintenance and end of life. So the readers can explore all of those areas. So that includes areas like material discovery and accelerate testing and R&D, process monitoring and inspection and manufacturing, kind of similar to what Nicolina showed, in-field data analytics, safety monitoring, and energy management once batteries are actually deployed. We also try to be clear that many of the most ambitious AI visions, like fully autonomous factories, universal lifetime prediction models, or AI discovered, golden recipes, are still very aspirational. The progress in AI is real, but adoption today is uneven and highly dependent on data quality, integration, and human expertise, which is still, of course, highly lacking in this new concept, and with the complexity of the data that comes from battery manufacturing and deployment. So the intent of this section isn't to claim that AI has arrived everywhere, but to map where experimentation is happening, what's working today, and where expectation should remain cautious. Yeah, so thank you, Mike.
We'll go over to Maithri and see what you have to add for us. But this stuff has been great. What a fantastic amount of data we're getting. And these are only a few of the how many hundred slides in the
700 this year.
Oh boy, it's going to be a great time.
Getting bigger and bigger.
That's right. Okay, Maithri, we'll turn it over to you.
Hey everyone, I am Maithri Venkat, and I am the author for the supply chain section this year. So we're going to talk about some key trends from the supply chain side. One thing you'll see is that in 2025, it was the policy and market psychology that were true price setters for battery materials. It was not exactly a simple supply and demand type situation. So policy is the total wild card here. The global market dynamics are increasingly being affected by sudden political moves, like, for example, the DRC's export restrictions or China's tax shifts, which can instantly tighten or inflate costs. Lithium prices in China spiked due to inventory squeeze and massive buying, especially from the ESS sector. So this demonstrates how quickly market sentiment can override existing supply. In fact, in case of cobalt, the mere threat of export quotas from DRC was enough to lift the cobalt prices. And this proves that uncertainty itself is a powerful commodity. And one thing you'll also see is that despite a perfect storm of rising input costs and increasing consumption in certain battery chemistry, the price of nickel refuses to climb regardless. So the bottom line is this: volatility aside, battery inputs remain cheap, and this ensures that the costs stay competitive.
Yeah.
I also wanted to share some insights from the battery recycling sector. We do see that we're witnessing a very high stakes race in the recycling sector. So where future profitably hinges on navigating strict new rules and securing a reliable stream of raw material. So like you mentioned, Mike, like policy is a big entry barrier. So while new import rules like China's acceptance of black mass, they open up huge market opportunities, they do come with extremely demanding specifications. So meeting these technical standards is now the defining challenge for some of the global predecessors. So we also think about the OEM lock-in. Many automakers are bypassing the volatile metal market by creating long-term fixed supply agreement with recyclers. And their strategy secures their material sources and shields them from sudden commodity price spikes. So despite the recent significant dips and swings in the prices of metals like lithium and nickel, long-term forecasts do indicate that the recycling industry is poised to become as valuable as primary mining. And this is with an anticipated expansion reaching up to 30%. And we also see that intense rivalry in key regions like Europe and China has led to factories operating below capacity and escalating competition for the limited available feedstock. So here's the punchline: the recycling industry's future is not about if it'll grow, but who will survive the current shakeout by mastering the regulatory environment and also locking down the supply chain.